All right, guys, good morning. We are going to get started in just a second here. Just poured myself some coffee, making sure all my stream settings are where they need to be. Let me know if there are any issues with the video or audio in the chat, please. I will keep that running through the stream, so if anybody has any questions or comments, go ahead and put them in there. There is about a 30-second delay between when I do something and when it appears on video, just FYI. Good morning, Alan. Good to see you. Today, we have the new camera model from Cinnado. The previous one has been one of our favorite devices in the Thingino project, largely because it is so cheap. You can buy these on Amazon. Their normal price is about 15 bucks, and you can often find a coupon. I've seen them for as little as like $9.50. And they're lower end cameras. They've got the lower end processor and lower end image sensor, but for the money, you really can't go wrong. They're very well supported, and they have all of the basic features, so everything actually works on them. You don't get the higher resolution, you don't get the superior night vision that you would get with some of the other models, but it is a really good entry-level device, and it's highly recommended if you are thinking about getting into the Thingino project and don't know if you're going to like it, don't want to put a bunch of money into it, or what have you. So, interesting thing with these, they are almost identical from a glance. You see the box here. If you didn't look at this part, it's the same box. And that does not change as we get deeper into the project. So I've got the old one here just so we can compare against it as we go. So first thing we're going to do, we're going to go ahead and pop out the old one. This one this one is running Thingino already, obviously. And just as a demonstration, I'm going to show you what this one looks like and how easy it is to open up. Now, I always say when you want to open your Cinnado camera, you just kind of wring its little neck and its head pops right off. And it's basically this. And its head has popped right off. Then to see what model you have, you just rotate it. The processor chip is right about there. And I need a little more light to see it. This one is the T31, so this is the original model. Now, we first got a hold of these in February, I think, right when the project was new, and got them, and it was really quick to bring up support on it. The flash process was really easy to build and really straightforward. And then right before I published a video on it, they came out with a new version that used the T23 processor instead of the T31. And so that all went on hold because we did not at the time have support for the T23. And it actually took us several weeks to get to the point where that was supported. I did videos on a bunch of other cams in the meantime. And finally, the T23 support got in, and I was able to update. So now we have instructions for both of those models. So today, what we have is they call it the 3K 5 megapixel dual band Wi-Fi indoor security camera. And they use their own measurements for how they come up with megapixels and how many K is in it. The 2K is a typical 1080p device. This one, I believe, is 2560 by 1440, otherwise known as 1440p. So let's go ahead and crack this guy open and we'll see what we've got. And we've got mounting hardware, we've got power supply, etc., etc. Not too interested in those. And there's the camera. you'll notice at a glance, these are the same. You cannot tell by looking which one's which. Even when you flip it over and look at the model, the bottom here, it's exactly the same. They've got different color stickers for quality control, but that's probably not because of the model. That's probably because they ran out of green and had more silvers. But they both just say IP camera model D1, power 5 volt 1 amp. So the only way I can tell these apart right now is I have a piece of green tape on the old model. So we can pretty much take for granted that the easy way to get into this is exactly the same. And we'll just ring its little neck, and its head pops right off. And here we have, let's get my extra light again. This one is a T41, and looks like it is the N variant. So the T31 and the T23, the T20, which you see in all the cams that are currently supported, those are the X-Burst 1 architecture, and that's kind of the original embedded from Ingenic, and that gives you one CPU core. It implies which ISP it has on it, what features it has, as far as memory, clock speed, things like that. The T4X series is the X-Burst 2 architecture, where now you have a dual core CPU. You have the potential for higher capacity memory, although I doubt we're going to see that on this lower end of the scale. And some other features are also updated, but I think the biggest difference is going to be that it's a dual core, slightly newer architecture. So let's go ahead and get rid of the old model. And we're going to need a Phillips screwdriver to start the disassembly. So it just so happens I've got one of those right over here. Now I've taken a lot of these apart, so I'm kind of gung-ho. Don't worry, it'll go back together. So this screw will detach the tilt motor from the chassis. And now this part should just pop out. There we go. Now here we have the wire for the tilt motor control. This will be for the pan. This will be for power. There we go. We are loose from the base, and we're going to go ahead and get the board all the way out. So we have to take off the tilt motor. Just 2 more screws. And then we've got 1, 2, 3, 4 screws to remove the board from, what would you call this, the face? If we're going to stick with that being the head, then yeah, this would be the face. And one more. And we should be able to, there we go, just pop it right out. All right. So here's something that's different on this one, is the Wi-Fi module actually has an antenna that's connected to the face, for lack of a better word. So we're going to go ahead and just pop that guy off. This one is supposed to be dual band, so 2.4 and 5 gigahertz are supposed to be supported. And my clip came loose here. Let's see if we can put that guy back together before we lose it. There, good enough. that good enough? Maybe. All right, we've got a little pad here. What are we keeping cool? Nothing. Little power regulator, motor controller. Seems pretty unnecessary to me, but what do I know? All right, so we're gonna look for the UART. Now, I don't recall where it is on the old model. It's been months and months since I looked at one. And yeah, it looks like I was a little ham-fisted and I actually snapped this. So I'm gonna set this over in the corner so we'll be able to put it back on when we're ready. Not worry about losing it. This is why I do these first, and then other people can come in and just copy what I've done. So here we have, this is the infrared light ring. All right, and we've got UART over here in this corner. We've got ground, transmit, receive, and 3 volt. So we never hook up the voltage. We only do ground, transmit, and receive when we do these, because you don't actually need the power. Now this connector here is for the infrared shutter. We'll go ahead and leave that connected. So I have, we'll see if it'll line up. I've got a nice pogo pin adapter here. Let's see if these will line up well enough. They may not, because there's a connector on the other end, but I think we can do it. All right. The pin spacing's different, but I think it's good enough. So ground, transmit, receive is what we've got. And 2 pins are on transmit. So let's go ahead and get started. Got my PTO UART adapter. And so black is ground, white is transmit. And skip one and then receive. All right, and I am going to need actually to bring power back on this. I might actually be on, is that power or is that a speaker? These things are not well labeled. I think that is actually a speaker. And that this one is, let's look. Yeah, that's what it is. So the connector that I scrooged up a little bit, we actually do need. So let's go ahead and get our cable back in theory. And then we need our clip. All right, little clip, you've got double duty to do here. If this is going to be an issue, I can steal a clip off of another device, but I think this should be fine. All right. All right, we've got power. Go back to UART, which is over here. Ground, transmit, receive. So we got those. Come over to our terminal program. Go ahead and plug this in, and we need USB-C. We'll go ahead and use the included cable so I don't have to dig for one. I like a lot of things. Oh, sorry, volume went down. Let me turn my gain up slightly. Hopefully this helps. This is supposed to be a non-directional microphone, but obviously I can't hear what's going on. So let's get power. Ready to go there. Let me set up my window for the terminal here. Here we go. And let's bring up terminal. Hopefully you guys can see that okay. Let me know if the volume is good now, by the way. Oh, see if I can type minicom right. All right, in theory, I've got these plugged. You know, I think I actually have transmit and receive switched on here. Let me fix that. Let's get it right the first time. All right. First plug. Did we get it? I'm thinking no. We did not get it. Maybe I hit it right the first time. Also possible that I don't have a good connection. But we'll do this first. All right. Seems we don't have a good connection. It is a little hokey with the pin spacing not being quite right. We'll just have a quick looky here. Yep, I think it just scooched a bit. Sorry, this part is not easy to film. There we go. Did it stop working? It started working, and then it stopped. Did this scooch again? I don't think so. Maybe. I think it's just slightly off. Obviously, the pin spacing is not ideal. Don't worry, we'll get it. There we go. All right, we're going to restart it, and we're going to try and get into the bootloader. There we go. Welcome to the bootloader. All right. Alright, so we have actually a really small environment here. Usually there's a lot of stuff in here, but not today. Let's see what all commands we get. It's pretty nice. We've got some commands for the SD card. We've got some TFTP stuff. We've got flash commands. We can change the environment. So let's see. Let me pop in an SD card. Alright, I was successful at getting the SD card without messing up my UART connection. Alright, MMC info. I wonder if I make this window a bit bigger, if it'll still be visible so we can see more of what's on here. All right, now it does see the MMC. So what would be great is if we can just read the flash directly from here and store it to the SD card. And let's see if I can remember those commands. Oh, this one has a 16 megabyte flash. The old version only has an 8 megabyte flash. The 16 meg will allow you to put additional packages on there. Like, I really like to use zero tier VPN, but it does not fit, currently it does not fit on the 8 meg devices. So that is super nice. So we want to read the flash, excuse me, and then store it to the MMC. And we want, starting at 0. Oh, we want to read to a location. And then we start at 0, and the length is 16 megabytes. Let me convert that to hex. So it's 1024 by 1024 times 16. There we go. Convert, okay. Things I should be able to do just from memory, but you know how it goes. All right, so we are reading from, did I miss a 0 here? Let's make sure we're doing this right. Reading from the SPI flash, we're storing it at the 16 megabyte location in memory with an offset of 0. So we're starting at the beginning of the flash, and we are writing to, or we're reading 16 megabytes worth of data. So we'll see if that does it. So far, so good. All right, so we've got it. Now we need to store that to the MMC. And I think I can just write it raw to the MMC card. So we're going to write memory. No. Let's see. Let's look at chat real quick. Oh, sorry. Let me adjust the window size here. Bottom of window is off screen. See if that fixes it. I wonder, can I just maybe shrink the terminal screen a little bit? To be able to get more visible. How's that? All right, I can see it all in my preview. How's that look? Great. All right, so I'm looking to see, we did not have fat right, which would have been ideal. Oh. We've got fat load and fat ls, so we can browse and we can read, but we cannot write to a file. And we do not seem to have Z modem or X modem on here either. So we can't just do it from serial. So we'll try using the MMC write. Let me make sure I'm doing that correctly. So MMC write memory address is there. Now this goes by blocks. Let me list our MMC so I see what our block size is. What was it? MMC info. All right, yeah, block size is 512. So MMC write starting at this address. Let me get the number of blocks out of here. 32K. Convert that to hex, and that is 8,000. Am I doing this wrong? Block number, start block offset. Okay, so we want to set that to 0, so it starts at the beginning. And then, oops, we want to do 8,000 hex blocks. We'll see if this works. It seemed awfully fast, but I don't mind. I don't think we need to do any sort of sync. I think we are just done. So let's see if that worked. Go ahead and power off the camera. Remove the SD card. And get our SD adapter. And we'll plug it into our friendly ThinkPad. All right, so we do have the card. In theory, I can extract that image with DD. Block size equals 1 meg. Count equals 16. Output file is D1. T41 dot image. What'd I do? Really? Okay, so we will change that. Times 1024, so we need this many blocks. Whoops, wrong window. Apologize for being a little clunky navigating through my windows here. All right, in theory, this is in theory, I could be wrong. In theory, we should have this image. Well, I did expect to see data right at the beginning, and I don't. This is definitely data from the image, though. See what Binwalk will do with it. All right, a lot. So we've got a ton of files here and a couple file systems. Now, as I recall, the Cinnado D1, the method for flashing it was just from the SD card. It was looking for a particularly named file. Now I wonder, do I have an offset issue here? So U-boot is usually the first 256K. So we will look at this with strings. And we will look for, here we go, yeah. So these are what we are looking for. Now, these are the file names you would see on a WANSView device typically. So the way that we flash these is we actually take our image and we can put it on the SD card with this file name, v4_all.bin, and that expects to see a full image that fills the flash. So in this case, a 16 megabyte image. If we only wanted to change U-boot and then let our U-boot do the work from there, we could do it as v4_boot.bin. But for the installer, I've always used all because it's just one step. So that's good to see. And so now what we're going to do is explore. Oh, thanks. It was capital M versus lowercase m. Yeah, I'm not surprised. Anyways, now we're going to explore the file system of the factory image and see what we can see. Excuse me. First, we'll have a little coffee. Or maybe a lot of coffee. So we'll go into the extracted images here, and so we've got a couple SquashFS partitions. So here we are. This is inside the user land, and what I like to do is start with the init scripts. So this is actually what it runs when it brings up the device. And these are just not quite bash scripts because they are running in BusyBox, which is usually the ASH shell, but it's very close to bash. So we can see what this does when it comes up. So we've got a sysconfig that is mounted. It's its own partition. It looks on that partition for a file called test.sh, and if it exists, then it runs it. So that's always fun. And if it doesn't, then we go into boot and we run boot.sh. So let's have a look at boot.sh. So just for the record, what we are looking for today, now that we've got the image, that's a good start. But we're looking to see if we can get some data on this device. Right now, we don't know what sensor it has. We don't know any of the GPIO settings. Those are all pretty important. We do have, we know what Wi-Fi chip is in here already because I looked at it visually. But we're also looking to see, is there anything interesting on here? So here's something. Check the SD card for an OTA upgrade package. So this is potentially another way that you could flash the device from the SD card. And so this is looking for a package, and then it's running this OTA upgrade, which is part of the factory firmware image. Now, usually that means there's going to be a specific format that package is in, so that's a little more difficult. It might be signed. It might be just specific sections of the firmware. We don't know that yet. And we probably won't try to find out, since we know we can just do the update using the v4_all. So we run this script, which is loading drivers that might have some of our GPIO stuff. Let's go back to the top here. So we are mounting here. First aid, that's probably doing a file system check, maybe some other things. We're loading the exFAT, which is the one driver that handles FAT32 and exFAT file systems. And we're loading the GPIO driver. We'll see if we have maybe module parameters for that, specifying anything. So we get back through here. RA0, not sure what that is. And then finally IPC start, which is going to be running kind of the main loop of the camera functions. So let's start at the top. So this is on a different partition. So we're not going to look at that yet because we don't have that mounted. Then we're going to start the shell command D. Let's look at that. Oh, that is not a script. See if there's anything interesting that we can learn from here. We can see what version of GCC this was built with. Not too much in there. So if we decide that's interesting, we can run that through a decompiler. We probably won't. Go back to our boot.sh and see what's next. Load driver.sh. So Wi-Fi driver. So here we now know what GPIO is used for the power to Wi-Fi. So that's good to know. We're going to go ahead and I'm going to copy these and put them in a different window, or we'll just do them here. Oops. This is just going to be for note taking. Wait, where'd I go? There we are. And so this runs mmcdriver.sh. So this is just loading some modules, nothing we can really determine from there. Go back to our boot.sh, see what we do next. We do that update if it exists. I'll look at this, but I'm sure that's going to be a binary. Yeah, no surprises there. We'll look at it, see if there's anything interesting we can learn just by looking. So we see it uses embed TLS, which is interesting. Previous ones I don't think used embed TLS. I thought I saw a file name in here when we were scrolling, but maybe I'm wrong because I went kind of fast. Some of the symbols in here obviously don't apply to this device, so this looks like it is probably a generic updater that they use for a bunch of different models. Here we go. What do we have here? Here's some of the text that we can find. None of this looks like URLs. I like when there's URLs in here because it can expose some interesting things. So just some basic output from doing an OTA update. And here's where it erases the flash before writing the new stuff. We've got some certificates. This is probably pretty similar in function to how we flash devices, really. And I will put this flash image up on my GitHub where folks can look at it if they're interested. Got some flags that are saved. Yeah, there's some stuff in here for SIM cards and 4G devices. This is always interesting when it sets up a bogus Wi-Fi network. I'll just kind of cruise through here quickly so we can get on to the next steps. Hacking into that is definitely not one of our goals for this stream. All right. Oh, what's our CPU info? That's an executable. All right, so we get down to the bottom and we're looking for IPC start.sh, which I believe is on a different partition. Which is probably this one, IPC start.sh. All right, so we'll look at this guy first. Create drv sinfo. Okay. So if it's empty, then it reboots. All right, well, that doesn't help. What do we do next? We look for a log config on the SD card if you have one, and if it exists, then it'll make this path and we'll put stuff in a log file. So that's interesting. And here we've got some settings for the ISP. Now let me get this to word wrap because we're going to want these. Put these into our notes. We don't need that one. I don't think we need that one. We need this one. All right. So that's good. It's interesting how generic these are. Like this one is checking to see if this device supports PTZ, because presumably they use most of these scripts on devices that cover their range, including ones that don't have PTZ. And we load a few more. We start something called BOA. We'll look and see what that is in a second. This is interesting. Fixed ISP core error. We better take that as a note. All right, let's go back up and we're going to look at what this boa.sh does. Is that not in? I thought that was where we were. MTD bin. Nope. So that's not here. That's somewhere else. Okay. We'll look for that in a second. Let's look at, well, we're doing some stuff here. Where is this MTD coming from? Because we've got create derv s info is here, but we don't have the boa thing here. Load sensor. So this is pulling from the sysconfig partition. So it's probably a good amount of information in there. So next we're doing a couple modules. We're running BOA, which does not exist. We're running app SD handle, which I'm assuming is just detecting and doing FSCKs. Now we've got several scripts in there, so that's doing app SD handle. Doing a bind mount of this to here. That's interesting. And then we're doing a file system check. Let's see what else is in there, because that is several scripts. So on insert, what do we do? Sometimes you'll find when the card is inserted, it's looking for a file and maybe doing something if that file exists. So this is just doing file system checks, so nothing that interesting here. We've got a script for formatting, fdisk, insert remove, and yeah, this is just setting up for auto stuff. Let's have a look at daemon.sh. Yeah, so this is just running the app, and if it runs and crashes 5 times, it reboots the device. And that is what, init app. Yeah, that is probably the big binary. Yeah, pretty big. All right, that one we looked at already. Let's see if we can figure out what sensor this guy has on it. Well, there's only one sensor included here, so I think we can assume that's it. Because they did not include bins for anything else. And here's all of the modules that we have. So we still have not learned the GPIOs around the motors. So we'll see if we can spot those. We've got some certificates. That's a different type of effort than what we're going to do. All right, we'll go back to our first partition. Now this one, the kernel was 4.x. But we don't have modules inside there. They're all just right here. Boa config. Okay, so that's just the web server. Nothing too interesting there. All right, so let's see if we can find that sysconfig. This is where we wanted it to be. It's probably going to be this largest one. Maybe not. Is it not minus X? Maybe it's minus E. Oh. Minus D. All right, didn't like that. Let's look at our U-boot image and let's see if we have the partitions clearly marked. Here we go. All right, so we can do a little math and we can get to where this sysconfig is. So we've got 256K. Just gonna do a little BC over here. And then we've got 2,304K. Sorry, I'm switching between windows here. Apologize for that. Then 3328K. Then we've got 9472K. Wrong window. 9472. Is that right? $256, 2304, 3328, 9472. So that gives us this number, and we will use DD to try and extract that. What do we call this guy? D1. Block size equals 1K. Count equals 1024. Skip equals that many. OF equals sysconfig. Okay, so that's actually GFFS2. Oh, I thought I had all this. Well, that did not dump any contents. Let's give it a minus V. I thought that was going to dump the contents. But it is just listing them. Well, that doesn't help. All right. So that is dropping all these files in here. All right, here we go. These are the files we're looking for. App system. All right, so we've got some settings for presumably motion, audio, RTSP, presets for PTZ. Excuse me. Let's look at core. Got more settings for the sensors. Oh, and looks like the sensor is actually a little bigger than I thought, 2880 by 1620, so that's nice. "15 frames per second, that's, oh, that's for channel 1. Still 15 frames per second, so that's not great. I wonder if that's a limitation of the sensor. We'll look into that later. So here's some stuff that's labeled GPIO. But does not actually call out which GPIO pins we're using for things. So I was hoping that we would be able to determine those. It's a little bit of a pain in the butt to look for them manually, but I've done it before. And so this is going to be, I think, stuff related to settings from their cloud platform. But we're going to look. Yep, nothing too interesting there. And I think that is it. All right, so let's go ahead. We'll real quick review what we've gotten done today, because we are pretty much done. We've gotten the firmware extracted. We have looked at the U-boot console, and we've seen what functions are enabled from there. We know how to flash using the SD card once we get to the point where we have an image for it. And we've determined what sensor we have. We have determined what Wi-Fi we have. So we've got most of what we need for the hardware. We've got a couple pieces of information here in our notes for this one's particularly interesting. I'll have to bring this to the guys and see what they think about it. We've got information on our clocks, which is very helpful. And I think that is about it. Let's see. Alan says, what about the starting zeros that I was concerned about? So there might actually be a slight offset there from where we expect to see it. But you know, I should be able to test that quite easily. And I think I'm wrong. I think those empty spaces might be expected because our partition offset was right when I did the math to get that sysconfig partition. Let me jump back over to there. Oops, don't want to close that one. So that was the sysconfig. And yeah, so this one starts right away. So that has the right signature, the right magic number at the beginning of it for a JFFS2 file system. So I think I was wrong about that offset. And we can look at another image. I think where I have another image. I for sure have more images on this box. Let's go. Should have some images in one of these. Oh, here, we'll look at this Galileo one. Actually, we have this older Cinnado D1. So starting at 0, maybe I was looking at it wrong. Starting at 0, we've got some stuff. Let's jump back over to the one that we extracted. Yeah, so I looked at it wrong. I thought this was noise, but this is correct. This is our magic numbers starting at 065432, and that signifies U-boot. I just completely glossed over that part. Jump back over to chat here. Yeah, so I am confident now in that image is a valid and complete 16 meg image. All right, so as I was saying, this was a fact-finding mission, and we learned about the U-boot. We have a good copy of the image. We got some of the details about the hardware that weren't obvious externally. We know what sensor we have. We've got info on the clocks, and we learned about the commands the U-boot has exposed. We know there's no password on the U-boot. Actually, let's look real quick at the password on this camera, and maybe we'll do a hijack, because we've got a hijack script for removing the password. Let's do that. Give me just a second to have a look at our shadow file. Yeah, look here. This is a DES password. This is not an SHA password. This one we could potentially get if we don't already have it. Let me check our wiki real quick and see if we already have it. If we do the hijack on it, I can actually boot the camera and log into it over UART, and we can look at what GPIOs are being used by the motors. Let's see, GitHub, MacTech Thingino firmware. I'm sorry I don't have this window shared. Somewhere in here we have the security, although it might not actually be on this one. Anyway, we're going to go ahead and we're just going to do the hijacker. And I should have that script in projects. Oh, this is the wrong box fit. Let me grab that script real quick. That's in the Thingino repository under scripts. Hijacker. Oh no. Cannot determine boot command. All right. Oh, I wonder if it is because we're using T41 instead of an XBurst 1. All right, so this is looking for MTD parts. We could probably fix this real quick. Why isn't it finding that? Oh, I bet it's because This is slightly different. This is SFC0 underscore NOR instead of just SFC0. SFC0 NOR. Let me look at that again. MTD parts equals SFC0 underscore NOR colon. Just want to make sure we do this right. Oh, I forget what it looks like on other ones. Let me reset here. Alright, so here we're just looking for FFC. So I really need to copy this into my notes instead of having to keep going back here. So MTD parts white space plus SFC, which we don't have. That should get us past the first one. It does, but then it fails later. There's some noise. Thanks for putting colors in here, Paul. Alright, so we need to get MTD parts equals SFC0. So that should be picking up properly. Root partition is whatever, offset is whatever. Boot command JZ SFC. This is not using JZ SFC at all. It is just doing the SFC0 NOR. Oh, well, it thinks it's doing it anyway. Although I've piped it through less, so it's a little ugly. Sorry about it being ugly. Yeah, so we're interested in the GPIO, and maybe we'll see something else along the way. Alright, this says it's done. We do have a 16 megabyte file, and I'm just gonna real quick look at the file Make sure we've got, yeah, so we've got our magic number for U-boot. We've got U-boot. As long as we've got U-boot, then I can always restore the image if I need to. So we're going to take advantage of that. I need to fix our SD card since I wiped it. That's SDA. Yep. New DOS primary, one partition, and entire thing. And then we want to set it to 95 FAT32 LBA, which is 0C. We're going to write it. Going to put a file system on it. Go ahead and get it mounted. And then we're going to copy our image here, our patched image over there. It's all owned by root. We're going to unmount it. Make sure we're good and synced. All right, pop our SD card out. So this should be interesting. I'm gonna go ahead and put it into our camera. All right, now I have bumped this a little bit, so we will see if we still have a good connection. But in theory, there we go. Go ahead and let it boot. I would say I don't have a perfect connection. I do see a little bit of noise on here. Let this thing... Oh, you know what? That totally did not do what I wanted it to do. I did not rename the file. That was a required step, and I skipped it. We'll just pop this guy back into our happy little ThinkPad. You know, sometimes stuff happens. Oh, v4 all dot bin. All right, we're gonna do this again. Oh, that's interesting. The camera just rebooted. Don't know why. SD card is inserted. Sure is a lot of noise. Let me just eyeball over here. Okay. Yeah, this shifted slightly. Try it there. That should be cleaner. Now we're going to power cycle. And in theory, this is going to flash our camera to our new patched, hacked firmware file. There we go. Here we go, here we go, here we go. Good stuff happening now. Just required a little modification of Paul's hijacker script. Good stuff. It's really nice being able to do this stuff without resorting to my Flash programmer, because I've got, the alligator clip, but those things last about one use for me. I don't know why. The pins on them just go toast on me. Oh, here we go. We are booting our hacked firmware image. And we'll let this do its thing for a minute. I do need to take a full boot log of this to share over on the Discord channel. But for the moment, I'm just looking. And here we are. We are logged in as root. Now we do have a pretty loud console here, unfortunately. Oh, what was this called? There is a command for mounting a particular file system to give us our GPIO debug. Let's see. Alan says, can I explain the hijacker script? I can. Give me just 1 second so I don't lose my train of thought here, if you don't mind. But absolutely. Just need to dig up where our debug FS is. Syskernel debug. That's it. All right, so here's some GPIO stuff, and none of it's labeled. Oh, no, it totally is labeled. What am I saying? Totally labeled. All right, let me grab that for my notes if I can get it quick enough. I don't think I did. All right, copy, paste. There we go. All right, that is super helpful. That tells us what pins are being used for PTZ control, and we can pretty easily figure out which one is which. We've got these little handy guys, which you plug into the PTZ motor port, and it will light up your LEDs when you set a pin high. So that will tell you very quickly which one you are fiddling with. And so we also got we already had our SD card power pin, I think. Now we also have our SD card carrier detect or card detect, and we've got our reset pin for the sensors. So those are good. All right, so Alan has asked, let me jump back to that window. Alan has asked, can I explain the hijacker script? So let me run over to the hijacker script and we will look at it together. We can go ahead and close Minicom for the moment. And we'll look at the hijacker script itself. All right, so there's a little bit of noise here. Essentially what this script does is it looks at the original firmware file, figures out where the partitions are, which is what we had to fix here because it's a little bit different on this device. Goes through all the partitions and finds their sizes and their offsets, then converts those values, which are in hex, into decimal, determines which one is our root file system, and that's where all of your main system files and configs are going to be. And we extract the root file system, do a full dump of it, uncompress it, unpack it, then we go through, and this is the business here. We blank out the password in the password file for the root user. We turn on a couple other things. We turn on the console if it's disabled, because not all devices have it. We enable Telnet for devices. If you have them connected to your network, you're able to use Telnet to access it. And then we repack the partition with SquashFS. We make sure that it fits and it's not too big. And then we will assemble a new firmware file with our modified root file system overriding the original one. So for any device that this script works with, if you have the original factory firmware, this will blank out that root password and allow you to SSH in directly. Or not SSH, sorry, you'll be able to log in from console directly, or Telnet if you have network connectivity on it. This one, having never been set up, like this was literally fresh out of the box. You were there when I plugged in power for the first time, so it has no network connectivity on it. So that is the hijacker script. I'll go back into Minicom. So this is going to be pretty noisy. It's going to be trying to do a lot of stuff that we don't care about. And I could set it up on a Wi-Fi network to do it over Telnet, but I'm not sure we have much more that we need to capture. So I'm going to do, I'm going to start logging. I'm going to do a full reset. We're going to break into the bootloader. We're going to interrupt the bootloader. We're going to do a help just to list the commands that are there. We're going to boot up so we get the full boot up messages, and we'll do a process list and go ahead and save that, and that'll be some useful data for the next steps. So step 1, unplug power. Step 2, enable logging. Step 3, plug in power. Oh, the SD card's still in there, so it's going to try and flash again. We're just going to interrupt that before it's done reading. Try this again. Oh. Well, I was mistaken as to what step we were at. I believe. Yep, I was a little hasty on that one. And now I need to get out my Flash programmer, because this was at the step of erasing the Flash, and now we don't have a bootloader. So that's fun. I don't know, you want to stick with me while I do that part of the process? What do you think? That was not something I was planning on doing on this video. However, it's definitely something that I can do. And I'll just be a little bit annoyed with myself about needing to do it. All right, well, I got one yes. I only have one person in chat who's actively chatting, and he says let's do it. So I say, why not? Let me just do a little eyeballing on this thing for a moment. That was a very silly mistake on my part. And actually this flash chip is in a weird spot, but I won't let that slow me down. I will take a up close high detail photo. before I make any modifications to the board. All right, got tweezers, flash programmer, solder, soldering iron. Now, if you guys didn't see my video on the pine sill soldering iron, I really like this thing. And it wasn't very expensive, and I have stopped using my main soldering station. I've been using this 100% of the time. This thing is great, and is USB-C powered, so super handy. Now here's the fun part, my hot air station. We'll go ahead and we'll just pause the ThinkPad for a minute so we can do this part. Let's see, let me get rid of the terminal. Let's see, Alan says we can't read the flash, won't it go to the SD card? Well, the short answer is that depends. And I am not set up for that. I am set up for this. So the nice thing about these chips is they're pretty sturdy. They don't mind getting a little warm. So we're going to get it a little warm. And this is basically how I do it. If you grab the chip with the tweezers, get a good grip on it, go ahead, fire this up, turn our temperature up, we'll say 350, give this a second to warm up. The weight of the board should be enough. Once the solder is hot, that it should just drop the board right off. All right, 350. The trick is not bumping any components that are next to it. I need to go a little hotter. Let's go a little hotter. These usually from the factory will have a little extra on them instead of just the solder. It makes it a little more difficult the first time you go to take them off. That was me. That was not the chip coming off. Make sure you use an additional hand. I've yet to figure out how to get an additional hand. That was me again. got the flash chip. Put the module over here. Give it a chance to cool down. And now we need to identify pin 1. Orient this correctly. Let go. Oh no, I got it switched. You have no idea how silly it is that I made that mistake that I made. But it happens. All right, now generally, we can use hot air to attach this one to our programmer. Which hot air do I have? I have a pretty cheap one. It is, let's see if we can get it into view here. It is the MeFix 858D Plus, and it was inexpensive on Amazon and does the job. See if my not too steady hand can get this lined up. All right, so I've got the chip more or less where it needs to go. On the programmer, turn the air pressure down a little so that I don't blow it off here. Oh, it moved. There. This is one of those things where a steady hand helps, which is not something I really have. I moved it too quickly before the solder had hardened. I might end up doing this just with the iron. We're gonna do that. Got the iron. USB cord. I'll just borrow the one from my laptop. All right, look at this. See how well you can see this. Can you see this at all? Let's see. Go back over here. Boom. Look at how quick this thing gets hot. That thing is ready to go. Drop this guy on. There should be enough solder already on these pins that I won't need to add anymore, I think. I might add a little more. Oh, that rotated on me. They do make clips for this. I think I have one. I should probably use it. Let me look. No, I think these are the wrong clips. Yeah, those are for through hole flash. Never mind. just gonna put a slight bit of solder on here. That should be good. All right, take our flash programmer, move our hot air station. Now we need the ThinkPad again. All right, back to the terminal with us. Terminal, there we go. Yeah. Let me out. It might not let me out until I have this port again. All right. Let's copy our image. Let's copy an attempt so it's easy to find. Now, I believe I needed to use sudo with this. So our programmer is ch341 SPI. We're doing a write. And our image is that. I did it wrong. 341A SPI. All right, well, it sees a chip and wants me to tell it which one it is. Well, that's a good question. What are our choices? We got a B, 128B. All right, let me get my flashlight out. And we'll get a close-up photo to get the exact markings off of this chip. $25, 102, or 25, 128. This looks like it says S. All right, we're just gonna give it one. Extra parameter found. All right. Now this process takes a little while, unfortunately. Being a 16 megabyte chip, flash ROM is very slow. So this would be a good opportunity if anybody has any questions, we can talk about it for a couple of minutes. So Alan says, nice on the soldering iron. Yeah, this thing was I want to say I paid about 30 bucks for this and a couple additional tips, and it has definitely been worth that. The soldering station that replaced it, I think I spent about 50 bucks on, and I don't use that thing at all anymore. This is supposed to be neat because it is open source and you can build your own firmware for it, which I have not done at all. That doesn't interest me for a soldering iron, but it's an interesting deal nonetheless. Just not a practical one for me. Let's have a quick glance over on Discord and see what's going on there this morning while we wait. Somebody had success using one of my installers for a Wise version 3. That's nice. Give him a thumbs up. Got a couple new members coming in. Go ahead and promote them. Let's see. Alan says shipping charge is just about as the difference in price to Amazon. Yeah, I bought mine directly from the manufacturer, and it ended up being a little bit cheaper. I basically got the extra tips for free in exchange for it taking an extra 10 or 15 days to arrive. So it was definitely worth that for me, because I didn't know at the time, if I was going to like it. And I definitely did not expect it to be as good as it is. So how are we doing here on our flash? We did the right. We're doing the verify, so we should be done fairly quickly. Gonna put some hot coffee in my cup. Give me 10 seconds. All right. We're not getting far without adequate amounts of coffee. Yeah, the hot air station, I think they are simple enough devices that it doesn't really matter so much which one you buy. This one has push button controls for the temperature, and I don't know if the temperature is accurate, but it definitely gets hotter as the number goes up. And it has worked for everything I have needed to do with it so far, so I'm pretty pleased. The important thing is it was cheap. Let me see how cheap it was. Amazon. It is no longer available on Amazon. Looks like I paid $32 for it about a year and a half ago, but the product no longer exists. These brands, they're all just made up. Need to watch this to make sure I understand all you did. Well, yeah, watch it again. The video will definitely be available for playback. Looks like our flash is done. So we can move on to the next step, which is getting the flash chip back off the programmer. And I think we'll go back to the hot air station. So let's switch away from terminal. Go back to here. Give it a second to warm up. All right, and same basic deal. We're going to let the weight of the apparatus drop the chip off once the solder's hot. So you get a good grip on the chip. There we go. And get rid of you. Use my solder spool to hold this. All right, look for our pin 0 indicator is there. Like the toughest part of this for me is just holding the component in the right place. So I think we're going to go back to our soldering iron. So what I like to do is just get one pin first on one side and then come back and do the other side. Just need enough to hold it in place. Theory, this is not quite straight, but all the pins are lined up. Looks pretty good, but not perfect. And a little bit of wandering solder, which I don't like. It's rare that I actually get this right in a single attempt. But this is looking pretty good. So we're going to find out. All right, give that a second to cool. Put the hot air station back away. And wake up our ThinkPad. I am reminded now that I've gone through that whole process that I only needed to program the first 256K to get the bootloader, but I did the whole thing. And my clip for the power cord dropped in. There it is. This is the clip that I goofed up, so I gotta be extra careful. I guess one other thing to point out on this model is this one uses the USB bus for the Wi-Fi, so you're not able to use cloner, which would have simplified that whole flash process quite a bit if it was available. I go back to our UART. Here, get plugged back in. Let's see. Mr. Thames, YouTube notifies me when I start streaming. They know what my favorite channels and topics are. Interesting that T41NQ is used in this small PTZ. For sure, this is the cheapest X-Burst 2 camera product that I've found, and being based on one of our existing favorites makes it an easy buy. Alright, let's jump back over, get Minicom running. Oh crap. You guys, you know, when you're doing something live on YouTube, you make mistakes, which you saw earlier when I made the mistake of aborting this thing while it was reprogramming the flash, made it erase it, bricked the device, and I had to do the manual removal and then reflash of the flash ROM. And this time I forgot to unplug the power, so when I hooked the connector up to the device, it booted. So here we are in our fully booted device. All right, there we go. So that was great. That was not what I intended to do, but it looks like the flash and the reconnection was all successful. So let's go ahead and we're going to do that log I was talking about. Step one is unplug the device. We're going to call this D1 log.text. So where were we? My steps were I was going to plug in the device, get the initial stuff from U-boot and interrupt it, which is, oh, it's too slow. We'll have to go back and do that part. But here we'll get all the kernel messages. We'll get a process list. Got a whole bunch of noise here from the streamer. All right, then we will reboot. We'll abort the U-boot. We'll do a help to show the commands that are available. And I think that's it. We'll close our capture file. We got everything that we wanted. All right, Alan says, can you give a close-up of the clips? Are you talking about the one that I had to, the one that I broke? Or which clip are you talking about, Alan? Let me know. I will definitely give you a close-up view. As I drink some more coffee. And while we wait for that delay, check my messages back over on Discord. And in the interim, I will decide if now is the time to reassemble the camera. I think not. I think it's going to go back into its box in pieces. Okay, yeah, Alan just wants to see the broken clip. So, unplug our camera. Disconnect our pogo pins. Disconnect our power. Now we'll see. Let me switch back to our top view camera. By the way, this top view camera that you're seeing here, this is a Wansview W7 running Thingino. So the clip in question here is this guy. And so this is a ribbon cable. This has the power and also the lines for the reset button and the LED on the back here. And when I was ham-fisting it earlier to remove the cable, as you can see, it has a little leg here, and I broke the other one. That's all. Not that bad. In practice, it's not going to mean anything, but it's annoying that I broke it. And I'll plug it back in. I totally have other devices with the same clip that I could just pilfer one. But I'll probably wait a little while before I do that, because I can see myself taking this thing apart a lot more times. There we go. So that one's good to go. All right, well, I think that is going to be about it for this live stream. We definitely got all of the information that we wanted off the cam. We were able to do a root account hijack, so we can now log into the device. We've got the bootloader information figured out. We actually have over on Discord, we have the beginnings at least of a U-boot that should work on this device. So that'll be one of the next steps for me, is to try using that U-boot to boot the factory firmware otherwise and kind of go from there. So I'm hoping, and this is not based on information from anybody other than myself, but I'm hoping that maybe around the new year we will have support in Thingino for this camera, and it'll go right onto our supported and probably recommended list if this is anywhere near as good as I expect it to be. So yeah, that's gonna be the next steps. We're gonna work on the bootloader, and then we will start working on the userland environment. The factory firmware as it is, I probably have everything that I need from it. So that's about it. If you are new to the Thingino project, definitely check out Thingino.com. There's information there. Feel free to jump in over on our Discord channel. That's where most of our development is done. We also have Telegram, which is a little less active, but you can get the link for that on our website as well. And I've got some links down in the description for some of the stuff that we dealt with during this live stream. I'll add a few more in there for some things that I didn't know I was going to be discussing. And definitely give me a thumbs up if you don't mind. I appreciate if you would give me a subscribe. Any questions or comments you have, go ahead and put them down in the section provided by YouTube there. I try to answer all of the comments and questions that I get. Next video should be coming up in 2 or 3 days probably, and is not going to be a video on cameras, so that'll be a little bit of a twist. Look forward to seeing you guys there. All right, until next time, stay fresh, cheese bags.